Okay, 8.2 is another distribution where we're going to do confidence intervals. But first I have to introduce a t-distribution. So t distribution is similar to z in that it is, it's not the normal. So the z distribution is your normal curve where everything's symmetrical. So the t-distribution you use instead of a normal distribution when you have a sample size of less than 30. So if n is less than 30 and or you don't know the population standard deviation. So for our confidence intervals, if you don't know the population standard deviation, you don't have enough information to do those z intervals. So on our z intervals that we've been doing, the calculator asks for population deviation. If you don't know that, you can't put it in. So we're going to use this thing called a t-interval. When you're dealing with other things, if your population's too small to be normal, we talked about this in the last section, the bigger it gets, it approaches normal. Well, if it's too small to approach normal, we use what's called the t-distribution. So with the t-distribution, the exact shape changes based on the sample. The bigger it gets, the closer it gets to normal. But we can use the t-distribution until it becomes normal. Because it's not normal, we use what's called the degrees of freedom, which is found by doing n minus 1. The mean is 0, just like with our normal distribution. It's more spread out. You use the t-score instead of the z-score. It's just t instead of z is for the letter. You're going to use s, so you're only going to use your sample distribution or your sample deviation instead of your population deviation. You use degrees of freedom instead of n to help alleviate some of that extra spread. And then when we're doing our confidence intervals on the calculator, you're just going to use t interval instead of z interval. Other than that, it's no different. So for you at this point, you're going to write t instead of z, and you're going to use t interval instead of z interval. The way you know the difference is if you don't know the population standard deviation. That's the important thing, or if n is less than 30. So let's look at a couple. Because other than those two things, it's exactly the same as 8.1. So example 1, suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects. So n is 15, that's less than 30. Using the sample data, construct a 95% confidence interval for the mean sensory rate for the population, assumed normal, which you took the following data. So it gives us a list of data, it gives us an n, and it gives us a percent. So we know we have a list of data. So we start by going into L1 and putting in our data. 8.6, 9.4, 7.9, 6.8, 8.3, 7.3, 9.2, 9.6, 8.7, 11.4, 10.3, 5.4, 8.1, 5.5, 6.9. Okay, so stat, tests, intervals. Now let's say you're not sure which one. If you go into Z interval, we're under data, the first thing it asks you is population standard deviation. If you read this problem, it doesn't give it to you. So you're like, I can't do it. I don't have the information. So that right there is a hint. Maybe I picked the wrong one because I can't enter the first question. So let's try the other one. Stat, over to tests, number 8, T interval. This one doesn't ask for population deviation. So this is the right one. So we're going to do T interval. List, I put it in L1. Frequency is 1 because I don't have any percents. Confidence level is 95.95. I don't need to enter an N for this one because I put the data in. And then I go to calculate. So the only difference is I pick T instead of Z. So 7.30 to 9.15. So there's my confidence interval, 7.3 to 9.15. 95% sure the mean falls in there. Why don't you do the U-try? All right, 8.2, 9.1, 7.7, 8.6, 6.9. For 12 subjects, so N equals 12, we want 95%. So we're going to go stat, tests, T interval, data is L1, 95%, calculate. So we're T interval. And we get 8.16 to 9.80. There we go. And I knew it was T interval because I didn't have the population deviation. So let's look at example 2. The Human Taxone Project, HTP, is working to understand the scope of industrial pollution in the human body. Scientists at HTP tested cord blood samples for 20 newborn infants, so that's our N. In the US, the cord blood of in utero newborn group was tested for 430 industrial compounds, pollutants, and other chemicals, including chemicals linked to brain and nervous system toxicity, immune system toxicity, and reproductive toxicity in fertility problems. Table shows how many of the targeted chemicals were found in each infant's cord blocks. Use the data to determine a 90% confidence interval for the mean number of targeted chemicals to be found. So same thing, I'm going to put this in L1, 79, 137, 145, 83, 147, 156, 160, 94, 116, 121, 100, 144, 159, 123, 151, 114, 156, 139, and 126.99. Okay, and then we weren't given a standard deviation, so I'm going to go to T interval. So T interval. It's data, L1, and we want 90%. So I get 120 point, so that's different than what I had. So I'm just going to double check my numbers again. Nope, I don't have 79. All right, and because there's only one set of data, I can just add it on the end. Order doesn't matter. There we go. That's better. So 117.41, comma, 137.49. And that would be my confidence interval. And then I just want to show you before you do the U-try, there's also a stats column here. So if you did the stats option, it would ask you for the sample mean, the sample deviation, and n. So same idea as the z interval. It just, whether it gives you a set of data or it gives you the stats. But why don't you go ahead and do the U-try and see how you do. So stat edit. So we would get 2.396 to 9.870. There we go. So that is 8.2. Everything else is the same because you're still using you're still using the intervals, you're still doing all of that. You're gonna do everything else the same. So that's 8.2. Let me know if you have any questions.